Hello everybody, I will start my today's another live coding session. So in my today's video, I will solve this question. So this is a completely new hard question for me. I will try. Okay, so show this distance from all buildings. You're given n by n grid of values 0, 1, or 2. Each 0 marks an empty run that you can pass by freely. Each 1 marks a building that you cannot pass through. Each 2 marks an obstacle that you cannot pass through. Buildings that I cannot pass through and obstacles that I cannot pass through. You want to build a house on an empty run that reaches all the buildings in the shortest total travel distance. You can only move up, down, left, and right. Return the shortest travel distance for such a house. If it is not possible to build such a house according to the above rule, return -1. The total travel distance is the sum of the distances between the house of the friend and the meeting point. Sum of the distance between the house of the friend. I see. And the meeting point. So friend? Oh. Which means there are people who are building in a house, maybe? You want to build a house on an empty run that reaches all the building and show the total travel distance. Yeah. The distance between the house of the friend and the meeting point. Okay, I will take a look at an example. The definition of this is a bit unclear for me. So in this case, 1 is the house, 0 is the road, path, and 2 is the obstacle. So given the 3 buildings at 0, 0, 4, 4, 0, 4, 2, 2, yes, and an obstacle at 0, 2. The point 1, 2 here is an ideal empty run to build a house, as the total travel distance should be 3 plus 1 is 7. It's minimal. I see. Okay, so yeah, my assumption was correct. So total travel distance is assuming there's a house somewhere, I choose the sum of the distance under each house. Okay, and I'd like to minimize it. Good. Okay, so in this question, the input should be to the array, and the output should be the integer, which is the minimum total distance, or -1 if it's not possible to build such a house, which means that there is an obstacle that I cannot go to my friend's house like this. So in this case, I cannot go to this house. So yeah, in this case, I should return -1. See. Good. Okay. So inputs should be to the array, and output should be the integer total travel distance, or -1. Okay. So like this, in this case, I should return -1. Good. And the 2D array has at least one row and at least one column. So yeah, good. Oh, and one more thing I'm wondering is there at least one, you know, house in a given grid. Otherwise, the distance should be 0 everywhere. Yep. And the answer is yes. At least one number 1 exists in the grid. Okay, great. So now I will think of this question. For the brute force approach, obviously, I will choose each position and do BFS to find total, distance. Yep. And I will return the global mini of total distance. Yep. Or -1 if any is found. Yeah. Or -1 here. In the case when there is at least one house which I cannot visit. I think this is the brute force approach, and assuming that there are, mn houses, I can start from mn places, and I will do the BFS. So it will take mn, time for each, because I have to visit all the cases in the worst case. So it should be mn squared. And m and n is 50, 50, so 2050. Oh, I think this is actually possible, maybe? Yeah, I think. This should be like this. Yeah, I think this is workable. Okay. Yeah. Hmm. So I will think of other approaches for a few minutes, and if I don't come up, I will go with this. So let's say, yeah. Let's think if I can do the BFS from each cell from the beginning. So in case of this, where I will think of better case. Yeah, I will go with the giving example. Yeah. I start BFS. Oh, wait. Yeah, it's okay. I will make it a bit longer here. I will start from each one, and I do BFS from here, there. And what I will find is if I start from here, I can say I reach here in one step. Yeah. Okay, so I mean, maybe I can do BFS from each house. Yeah. And for each cell, I will calculate and for each cell, I will have the distance of list or map. So maybe from 0, 0, maybe something, and maybe from 0, 4, it takes around maybe 2, and for 0, I don't know, 2, 2. I'm writing some random number here, 5 or something like that. For this, I can find total travel distance. Yeah. For each 0 cell, I will calculate this and get a total travel distance, and I will return the global mini of these total travel distances. Total travel distance, yeah. Or I should say this should be mass dot infinity if there are some cells which I cannot reach from. Or there is, yeah, at least one cell which cannot reach to this cell from. So obviously, if this is mass infinity, I will return -1. Yeah. So I think this is a better, I think. In the worst case, it's the same because there, okay, the time complexity should be because I do the BFS from each one cell can be up to mn, and for each BFS, it takes mn time. So this is the total time for BFS. And for each cell after that, I have to calculate the total travel distance, which takes mn times mn, because there are up to mn cells in the distances, mn keys, So I have to take a look at each of them. And there are up to mn 0 cells, so it should be mn times mn. So it should be mn squared gain. Yeah. But I think this can be smaller than this at least, because as I said, I assumed the worst case for number of zeros, and I assumed the worst case of number 0 at the same time. Yeah, but it doesn't happen all at the same time. Maybe in the worst case is mn divided 2 zeros and mn divided by 2 ones. Yeah, anyway, the time complexity is the same, but I think this is more efficient. Yeah. Okay, so I will start the implementation with the optimized approach. Yeah. Or maybe there is a better approach. Let me think. Yeah. Okay, let me implement with the second approach. So I want the 0 to distances. So what should I say? 0 to I said I will do. Okay, yeah, I will do that. There should be cell like something to dist. This is cell. Yeah, rest of this. Cell to distance. Cell to distances until houses. You let me just code house distances. And from here, I will do the BFS from each house. Yeah. If this is 0, no, house is 1. In this case, I will start BFS from here and update this house distances. Okay, so let me make it another message for this. Find I should say add house distances. So let me make it instance variable and I will give just and let me make read as your distance, just variable 2. Yep. And this is the starting house and append distances until each empty cell to self.house distances. So this is what this method will do. Okay. Okay, so once this is done, now I have the self.distances map. And one thing I have to take care is, it is possible that there are some houses that I cannot visit. So I somehow have to notice that. Yeah, I think it is possible to notice that while I'm doing the BFS. So but let me do that after it. It doesn't change the time complexity. So, num houses. Let me cache it. So, and what I will do is I will take a look at each, wait. No, this should be default predict. Or maybe set. This is fine. So here, this should be the distance until 1. Yeah. It should be the list of distances. Okay. So for each cell, it doesn't matter which cell I'm taking a look at. So let me do that. I will take a look at only values here. So now I guess the distances array. So if length of the distance is not terms of num houses, I will return -1. No, I shouldn't do that. I can just forget that cell because I can't build house there. Yeah. I just want to confirm this. Length of the distance is small. Num houses. Yeah. Okay. So otherwise, let me do that here. Length of distance is equal to length of the 7 num houses, as expected. So I will calculate the total travel distances. Yeah, I think maybe, okay, I will talk about it later, but I think I don't have to put list here and I can save the space complexity, but it doesn't affect the time complexity, so I will talk about that later. Okay, so this is how I update the read. Read should be the global mini total distances. Okay, let me change this to local. No, this is a local mini. Just total distance, fine. Okay. And I will return global mean total distance if this is not mass at infinity. Otherwise, I will return -1. Okay. Good. Now I will implement 2 helper methods. I will go with this one. Okay. And add house distances. So I will do BFS. Add So deck. So I'm writing the typical BFS. So for each previous cell, I will take a look at each adjacent cell. Okay, so now I've got the current cell. So here I will do the validation. Firstly, it has to be in bold. And also, I will check if it is 1 or 2. Okay. If it is 2, I just have to skip. But if it is 0, okay. Yeah, I will check. If this is 0, I just append to queue because I can keep going through the cell. Or if it is 1, I have to, update house distances. One more thing I have to take care is it has to be not visited yet. Yeah. Because I should not visit the same cell twice. And here I have to append to the visited cell. Okay. So from here, I will check if it is on bold. Okay, so now I confirm that current cell is 0, 1. So if the current cell is 0, I just have to visit the cell. So append like this. Yeah. Otherwise, I will append the cell to self dot, where is it? House distances. Yeah. Like this. And anyway, I have to append this to current dist. Oh. Okay. And this is it. Good. Okay, let me walk through my code. I don't take that much time for this because if I try the complicated example, it will take so much time. Oh, by the way, I said I think I can optimize this by not having house distances. Yeah, but let me. Yeah, but let me go with this for now. And let me do the space complexity analysis after dry run to have the more clear image for this. So let's say, very simple example. I will do this. Okay. In this case, I expect to return 1. Because here 0 is the house I can build, and the shortest travel distance sum should be 1 because there's 1 only. Obviously, I should check more complicated test cases to cover all the possible scenarios, but I will go with that to simplify and save the time. Okay, so here n rows is obviously 1 and columns is 2. Self.grid is grid, yes. And self.house distances should begin with empty default dict list. Good. And in line 50, I do BFS from each house. So here I start with row 0 and column should be 0, 1, 2. And let me take a look. Grid 0, 0 is 1, yes. So I call this one. Okay. So I will do it. Now I go to here, line 71 with 0, 0. And Azad 0, 0 is 1, yes. And number of rows, number of columns, this should be 1, 2. Q should be initiated with 0, 1, 0, 0. And visited should begin with 0, 0. Okay. Then current distance begins with 0. And now current distances becomes 1. And in line 81, length of the queue is 1. So I iterate only 1 here with range, which means that I will take a look at only a single element. And q.pop left, and I get pre-pro prim column is 0, 0. And I will take a look. So Actually, current row, current column pair. I will calculate this first. Should be 1, 0, and negative 1, 0, and 0, 1, and 0, negative 1. I will think of this, take a look at from here in parallel for each of them. I will check in both, and I have to check current row is 0 to 1, and current column should be 0 to 2, 0, 1, 0 and 0, 1. So I can say only this remains. So from this dies. Okay. So now it should be 0, 1. And here in line 92, grid 0, 1 is 0. So yes, go to line 94. 0, 1 is not visited yet. Yes, so I go to line 97. 0, 1 is 0, so I go to line 98. And 0, 1 is appended to 0, 2. Then I go to line 102, and 0, 1 is appended to visited. Nice. Okay, and I come back to line 80. 1, yes. And 0 is one element in the queue, so range 1 again. So I start with 0, 1 here. I will say my time from here. Actually, from 0, 1, I cannot visit any cell because from here, the only adjacent cell on the board is this or this. And for the 0, 0, 0, it already visited, so I skip. For 0, 2, it is equal to 2, so I skip. So in the end, that's the end. And this is the end of the while loop because there isn't any more element in the queue. Oh, by the way, current distance should be 2 when I started that traversal, but it doesn't matter. Okay, so now I get wait a minute. No, I'm taking a look at distance until 0. So if it is 0, I have to update house distance is. And if it is 1, what should wait. If it is 1, I can just simply ignore it because from each one, I'm taking a look at the distance until 0. Yeah. So this should be like this. So now I can say this is 0. And I just have to append this to Q. And also update the distance with this. And visit add it to the visited list. Yeah, simply I have to do that. Again, I would say I'm checking the distance from each one and until 0. So any 0. So this should be like this. Okay. So now I've got what get. Oh, I didn't update this. But I would say this should be 1. So 0, 0 has only element 1 here. Yeah, as appended here. Good. So what I do is, okay, I will skip my time. Sorry, I have to do row 0, column 1 case. And it is not 1, so I go to the next step. And when I take a row 0, 2, it is 2, which is not 1. So I skip. And it's the end of this double for loop. And I go to line 57. Global mean distance, total distances begin with infinity. And here, there's only one item, 1, rest of 1. So this is the current distances. And ranks of the distance is 1. Self of num houses is now 1. I don't check this helper method. I'm pretty confident. I never check if something goes wrong. And so in line 97, this is true, so I go to line 62. And ranks of the distance is equal to self of num houses. Yes. So this should be this. Yeah. And in line 63, total distance should be 1. Yes. And global mean total distance is updated with 1. So it becomes 1. So now this is 1. And that's the end of the for loop. So I finally return 1. Okay, passed. I passed this test case. So I covered almost all the lines. Yeah. I checked this in bold and this was covered. Yes. So I covered all the lines, even though I haven't covered all the possible scenarios. So I'm confident in my code. I will submit. Okay. Oh, length of the distance. What's the matter with this? Let me take a look. Distances is 0, 1, and 1. Something is wrong. I will check what is appended. Somehow, okay. Now I will check this one. I think this is good. Oh, okay. Not items, but it should be values. The name region is not defined. Yes, I changed it. Good, accepted. I submit my code. Okay, accepted. Great. So I will do the space, check out space complexity analysis. So the data structure I used are first 3 in the main method, self.house distances. So there could be mn keys, and distance could be up to mn. It should be mn times mn for house distances. And aside from that, global mean distances is just an integer variable. Num houses, no, this is an integer with cache. But yeah, only single integer. And in line 65 distance, it's just a reference to the values of the hash map, default dig. Okay. And in line 74, there is in the helper method, there is a queue. So this queue has up to mn elements. Yep. No, actually it doesn't. It can take up to many of mn, I guess. Because when I start from here, the the cells which are same distance from this 0 should be like this. And if there is even if there are so many columns, if the row number is limited to 3, just 3, it should go like this. The number of elements in the queue can be up to 3, which is minimum mn. Okay. And aside from that, what queue? Okay. Yeah, I think this is and the business set. For business set, obviously this should be up to mn because each cell can be stored. Okay. So with this, the space compressed D should be mn times mn. Yeah. So that's the space compressed D. Actually, I can optimize this space compressed D by just storing the house distance total. It should be xy to the total distance until 1. And when I'm doing the BFS from each house, if I find that there is okay, so I can say if there is zeros which couldn't be visited in this BFS, I immediately remove that as a candidate of the houses. So in that way, I think the space complexity could be O of mn. Yep, but I didn't do that this time. Okay, so I will quickly wrap up with today's coding practice. So today I solved this question, shortest distance from all buildings. And what I did is, so in this question, I was given the 2D array, and 0 represents the path, 1 represents the friend's house, 2 is the obstacle. So my task is to build a house somewhere on 0, and the house should meet the conditions that all the total path lengths until each friend's house, the sum of them should be minimized. So that's the condition. And in my solution, I use the BFS from each friend's house. So from each friend's house, I do the BFS and find out the distance until each 0. And after doing that, for each 0, calculate the total sum until path length till the friend's house. Then I return the minimum one. Okay, so that being said, I finished my today's coding practice. Thank you so much. Bye.